Hey guys! So today we're talking about independent and dependent events, and we're going to get about halfway through this, all right? So we need to talk about some symbols first. So if you ever are seeing something that looks like this symbol right here, no, hold on, let me get my little pen. This symbol right here, this means or. This is the union of two sets. So like if I had a Venn diagram, or would be everything in both circles. This means intersection, okay? Or and. It's where both are happening. So this is the intersection or where both are happening. Or is the entire thing. P of A means probability of A. Hopefully you figured that out. We've been using it a lot. Then the probability of A. So this one, if you want to try it now. This would be the probability of A or B. And obviously you could have the probability of A and B, which is B, that union symbol. Okay, we're going to talk about these next things that are more important for today. That's just some symbols that you're going to be seeing on your homework tonight that I need you to be able to see. And I'll try to use them throughout this lesson so that you're more familiar with them. So independent events are when outcomes of one event does not affect the outcome of the second event. So the two events are independent when that happens, when one does not affect the outcome of the other. Okay, dependent is when they both could happen. They have the equal likely chance of happening when one happens, when the other one, when it doesn't happen, they're just dependent of each other. So they do not affect each other's outcomes. Mutually exclusive means that they cannot happen at the same time. So the events are mutually exclusive. A and B cannot happen at the same time. Now we're going to practice this a little bit. So one's going to be independent, one's going to be dependent, and then on the next one, one's going to be exclusive and one's not going to be. So on this first one, tell me if it's independent or dependent. So a letter is selected at random, and one of the remaining letters is selected at random. Did it affect the probability? Yes, it did. So this one is dependent because it says remaining letters. That means they pulled it out and then didn't put it back in. It changed the amount of stuff in the bag. That changed the amount that it's out of. So we went from like out of 20 to out of 19. That was greatly affected. It may not super affect the probability there, but it does affect it. Okay, the next one says the color of a truck is randomly selected and the size of the engine is randomly selected. Do those affect each other? No. So these are solidly independent. Okay, so on this next one, two number cubes. A pair of dice are tossed. Determine whether the events are mutually exclusive or not. Explain your reasoning. So remember, mutually exclusive means they cannot happen at the same time. So the sum is a prime number and the sum is less than 5. Are there any prime numbers less than 5? Well, let's look. So this would be like 1, 2, 3, 4. Are any of those prime? 2 of them are. So these are not mutually exclusive. Okay, so the numbers are equal and the sum is odd. So first off, let's think about this. If you have two even numbers and you add them together, what do you got? You get an even number. Okay, that's not too bad. What if you take two odd numbers? Which remember, an odd is an even plus 1. I'm going to denote odd with 2 D's. So it's an even plus 1. So if we do an even plus 1 plus an even plus 1, the 1 and 1, what does that become? 2, and that's even. So two odds equal an even. So are those mutually exclusive? Yes, these are mutually exclusive. Because you cannot have the numbers be equal and then the sum be odd. You can't, that's not going to work. All right. Hopefully you guys understood that. If not, go watch it again. Okay, finding probability of dependent events. This means that one's going to affect the other, okay? All right. So the drawer contains 10 white socks, 6 blue socks, and Caleb reaches into the drawer without looking and randomly picks 2 socks. What is the probability he selects 2 blue socks? So the first blue sock he's going to have, so first off, there's 16 drawers on this, 16 socks in this drawer. That's important. So the probability of 2 blue socks. So that's going to be a 1 out of, or 6 out of 16 chance, right? Times, then all of a sudden it'll be a 5 out of 15 chance. And you multiply probabilities together if you want to know the probability of both happening. So we're going to multiply. So we're going to do 6 times 5, which is 30, and 16 times 15, which is 240, which is 3/24, which is really just 1/8, which is 12.5%. That's not super likely. So what's the probability that he selects 1 blue sock and then 1 white sock? So that, again, is 6 out of 16. But then the white is 10, and then this is out of 15 now because he selected the sock and pulled it out. Okay, so this would be 60 out of 240, which is about a fourth, right? Because 6/24 would be 1/4. Now I'm questioning myself. Yep, 1/4, which is 25%. That's not bad. So what's the probability that selects no blue socks? Okay, so that would be the probability of selecting, oh shoot. I was worried about this. So that'd be the probability of not blue. So the probability of not blue is all the white socks. So that would be 10 out of 16. Right? And then 10 out of 16 would be 5/8. Let's just do this. So you'd have a 62.5% chance of making that happen. He has a greater chance of getting a pair of white socks. There you go. Well, that makes sense because 10 out of those are white. Okay, and this next one. A basket contains 10 yellow, 8 white, 2 orange tennis balls. Without looking, she just pulls out 3 tennis balls. So first off, how many tennis balls are there? There are 20 tennis balls. So she randomly pulls out 3. So what's the probability she selects 3 yellow tennis balls? So in the beginning, there are 10 yellow tennis balls out of 20. And then there are 9 tennis balls out of 19. And then there are 8 tennis balls out of 18. Cool. All right, so the first thing I know is 10 out of 20 is really just 1/2. Is there anything I can reduce here? Well, I can see that 9 and 18 is really just, this can really just be a 1, this can really just be a 2. If this is 8 divided by 2, this whole thing just becomes 4. So this is really times 1/19 times 4. So I can type that into my calculator fairly easily. So I'm going to do 1/2 times 1/19 times 4, which is 2/19, which is approximately 10.5%. Okay, what's the probability she selects no white tennis balls? So that's just the probability of not white. So that means I'm going to take everything that's not white and add it together. So that is 12/20, because that's 10 yellow and 2 orange, which is only 12. which is then 60%. She has a 60% of pulling out no white tennis balls. So 2 cards are drawn from a deck of 52 cards. Determine whether it's independent or dependent. So we'll use I or D. And then find the probability. So what's the probability of selecting 2 diamonds when the first card is replaced? So first off, we need to know how many diamonds. So if I'm selecting 2 cards and I replace the first card, is that changing my probability for the second one? No. So these are independent. Okay, next thing I need to know. How many diamonds are in a deck? So in a deck of 52 cards, 13 are diamonds. So this would be 13 out of 52 times 13 out of 52. Now 13 out of 52 is 1/4 times 1/4. So I have a 1/16 chance, which is approximately, no, I don't remember what that is as decimal, 6.25%. That ain't bad. Okay, what's the probability of selecting 2 diamonds when the first card is not replaced? So this one is, in fact, dependent because we're changing the amount that it's out of. So I have 13/52 for the first one. And then I'm going to be timesing by 12 out of 51. Because all of a sudden there's one less card, there's one less diamond, and there's one less card in the deck. So I have to do this in a calculator. So I'm going to do 13 times 12. I get 156 over 2,652. Which is 5.88%. So it dropped. Do you see that? Okay, so a king is drawn, is not replaced, and the queen is drawn. So how much does that affect? Does it affect? Yes, it does, because it changes the amount of cards that we have in our deck. So this is, in fact, dependent. So a king is drawn. There's 4 kings out of the total 52 cards times the 4 queens, but now there's only 51 cards. 51 times 52 is 2,652. And 4 times 4 is 16. So I'm going to do 16 out of 2,652. And I'm going to get 0.6%. That's a very low probability. Not looking great. Okay. And that's what we're going to call today